In this video, we're going to review scientific notation. So what is it, and why do we use it? Scientific notation is a simple way to write very large numbers or very small numbers. For example, instead of writing the number 1 billion, which has a lot of zeros, you could simply represent that value by writing 1 times 10 to the 9. Instead of writing, let's say, 0.0000064, you could simply write 6.4 times 10 to the minus 6. So scientific notation is very useful for representing very large or small numbers. So you need to be able to convert a number from scientific notation into decimal notation or standard notation. Let's start with examples relating to that topic. For example, 4.5 times 10 to the 1. How can we convert this number from scientific notation to decimal notation? 10 to the first power is simply 10. 4.5 times 10 is 45. Now what about these examples? 2.3 times 10 squared and 7.4 times 10 to the third. Go ahead and write these values in decimal notation. 10 squared is basically 100. So it's 2.3 times 100, which is 230. 7.4 times 10 to the 3 is 7.4 times 1,000. 10 to the third is basically a 1 with 3 zeros. If you multiply 7.4 by 1,000, you get 7,400. Another way in which you can do this is you can move the decimal 3 units to the right. So for example, if I have 4.28 times 10 to the 4, I just need to move the decimal point 4 units to the right. So I have a 4, it was here, that's 1 space, 2, 3, let's add a 0, and then 4. So the decimal point is now here. It's equal to 42,800. Try these examples. 2.7 times 10 to the 5, 8.36 times 10 to the 7, 4.154 times 10 to the, let's say, 9, and 3.165 times 10 to the 3. So if it's 10 to the 5, you need to move the decimal 5 units to the right. So first, let's write a 2, a 7, and then let's move it. So this is 1, and then this is the second place, so let's put a 0 there. And then 3, and then 4, and then 5. So here it is. That's 270,000. So let's try the next example. So the decimal's here. 1, 2, 3, 4, 5, 6, 7. So basically, that's 83,600,000. Now for the next example, it's 10 to the 9. So here's the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 4,154,000,000. Now the last example is straightforward. We just got to move it 3 units to the right. So it's going to be after the 5. So it's 3,165. So as you can see, whenever the exponent is positive, the number is very, very large. But what about when the exponent is negative? Let's work on some of those examples. Let's say if we have 3.4 times 10 to the minus 2. What is that equal to in decimal notation? So when you have a negative number, it's going to be less than 1. It's between 0 and 1. Overall, it's still positive, but it's just very small. So first, let's write 3.4. This time we're going to move the decimal 2 units to the left. So this is going to be 1 and then 2. So this is equal to 0.034. Let's try some more examples. Try these two. 4.5 times 10 to the minus 3 and 3.746 times 10 to the minus 4. So first let's write 4 and 5. The decimals here. This is 1, 2, 3. So now the decimals here. So this is equal to 0.0045. Now for the next example, we need to move 4 spaces to the left. 1, 2, 3, 4. So this is going to be 0.0003746. So now it's your turn. Try these problems. 2.47 times 10 to the minus 3, 4.61 times 10 to the minus 5, and 2.973 times 10 to the minus 8. So let's start with this problem. 1, 2, 3. So this is 0.00247. Now what about the next one? So we got to move 5 spaces to the left. 1, 2, 3, 4, 5. So this is 0.0000461. Now for the last one, we got to move 8 units to the left. So this is 1, 2, 3, 4, 5, 6, 7, 8. So it's 0.000000. It looks like we have a total of 7 zeros and then 2973. So initially we were here and we traveled 8 units to the left. It's always good to double check, but this is the answer. Now let's work backwards. Let's say if we have a number in decimal notation, how can we convert it to scientific notation? So this is 4680. The decimal point is here. So if you recall, large numbers are associated with positive exponents. Small numbers are associated with negative exponents. So for this problem, we should have a positive exponent. Our goal is to move the decimal between the first two numbers, that is between 4 and 6. 1, 2, 3. So we got to move it 3 units or 3 spaces to the left. So it's going to be 4.680 times 10 to the 3. Now you really don't need the 0. You could add it if you want to, but we can leave the answer as 4.68 times 10 to the 3. So let's try some more examples. What about 32,500 and 476? Convert these numbers to scientific notation. So in this example, we got to move it 1, 2, 3, 4 spaces to the left. So it's 3.25 times 10 to the 4. And for this one, we need to move it 2 units to the left. So this is 4.76 times 10 to the 2. Try these. 37,950, 450,000, and 38 million. Convert it to scientific notation. So the decimals here, we got to move 1, 2, 3, 4 units to the left. So it's 3.795 times 10 to the 4. For the next one, we got to move 1, 2, 3, 4, 5 spaces to the left. So it's 4.5 times 10 to the 5. And for this one, we're going to move 1, 2, 3, 4, 5, 6, 7 units to the left. So it's 3.8 times 10 to the 7. Now let's try some examples with very small numbers. Let's say if we have 0.024. We need to move the decimal point between the first two non-zero numbers. So we got to move it 2 units to the right. So therefore, it's going to be 2.4 times 10 to the minus 2. Now what about 0.00036 and 0.00071? Try those. So for this, we got to move it 1, 2, 3, 4. So this is actually not 4 units, only 3. I take that back. So 1, 2, 3. We need it between the 3 and the 6. So this is 3.6 times 10 to the minus 3. And for this one, 1, 2, 3, 4 units to the right. So it's 7.1 times 10 to the negative 4. Now I want to highlight something that's very important. So let's compare these two problems, 0.086 and 4254. Right now, each of these numbers are multiplied by 10 to the 0, because 10 to the 0 is 1. Anything raised to the 0 power is 1. When we move the decimal point to the right, the exponent will decrease. It decreases by 2. So this becomes 8.6 times 10 to the minus 2. When we move the decimal point, let's say to the left, the exponent increases, in this case by 3. So this is 10 to the third. So make sure you know this. Anytime you move the decimal point to the right, the exponent is going to decrease. If you move the decimal point to the left, the exponent will increase. For example, let's say if you have the number 42.8 times 10 to the 5. This number is not in proper scientific notation, because in scientific notation, 42.8, that number shouldn't be more than 10. It should be between 1 and 10. So we got to move the decimal point 1 unit to the left. The decimal point should be between the first two numbers in order for it to be in proper scientific notation. So if we move the decimal point 1 unit to the left, what's going to happen to the 5? Should we increase it to 6 or decrease it to 4? Anytime you move the decimal point to the left, the exponent will increase. So we should increase it to 6. So this is 4.28 times 10 to the 6. Now if you wish to prove it, here's what you can do. 42.8 is basically 4.28 times 10. You can prove that with a calculator. And 10 to the first times 10 to the fifth is 10 to the 6. If you recall from algebra, whenever you multiply two common bases, you can add the exponents. 2 plus 3 is 5. So 1 plus 5 is 6. And that's how we can get this answer. Convert the following numbers into proper scientific notation. So let's try 37.4 times 10 to the 5, 426.8 times 10 to the 7, 0.0046 times 10 to the negative 3, 0.081 times 10 to the minus 4, and let's say 76.1 times 10 to the negative 5. So let's remember the general rule. Whenever you move the decimal point to the left, the exponent will increase. And if you move the decimal point to the right, the exponent should decrease. So always keep that in mind. In the first example, we're going to move it to the left. That is one space to the left, so therefore it should go up. So it's going to be 3.74 times 10 to the 6. Now let's try the next one. So this time we got to move it 2 units to the left. So the exponent should increase by 2. So it's 4.268 times 10 to the 9. Now, for the third example, we need to move the decimal 3 units to the right. So therefore, we need to decrease the exponent by 3. So it's going to be 4.6 times 10 to the minus 6. For the next one, we got to move it 2 units to the right. So it's going to decrease by 2. Negative 4 minus 2 is negative 6. So it's going to be 8.1 times 10 to the negative 6. And then for this example, we got to move 1 unit to the left. So it's going to increase by 1. So it's going to be 7.61 times 10. Negative 5 plus 1 is negative 4. So anytime you move into the left, increase the exponent by the number of spaces that you move to the left. And if you're going to move to the right, decrease it. Now let's go over a mixed review. Convert the following numbers into decimal notation. Let's see if you remember everything. So let's say if we have 42,900, 0.0476, 3,856, and 0.00024. So in the first example, we have a large number, so the exponent should be positive. So we got to move the decimal 4 units to the left. As you move it to the left, it's going to increase 4. The exponent is going to increase by 4, starting from 0. So it's going to be 4.29 times 10 to the 4. As you move it to the left, the exponent goes up. Here, we're going to move it to the right, particularly 2 units to the right. So starting from 0, the exponent will go down by 2. So it's going to be negative 2. So it's 4.76 times 10 to the negative 2. As you move the decimal to the right, the exponent will decrease starting from 0. For this example, we need to move 3 units to the left. So it's going to increase by 3 relative to 0. So it's going to be 3.856 times 10 to the positive 3. And if we move it to the right, it's going to decrease starting from 0. So it's going to be negative 4. It's going to go down by 4 units. So 2.4 times 10 to the minus 4. So as you recall, small numbers like this one are associated with negative exponents. Large numbers are associated with positive exponents. Now let's work on converting it from scientific notation to standard notation or decimal form. So let's say we have 3.89 times 10 to the 3, 4.21 times 10 to the minus 4, and let's say 39.7 times 10 to the 5, and 468 times 10 to the minus 5. So we know that a positive exponent will give us a large number. So this is going to be, we need to move 3 units to the right, so it's going to be 3,890. Now for this example, we got to move to the left. Negative exponents will give us a small number. So 1, 2, 3, 4. So therefore it's 0.00421. That's the answers to the second problem. Now for the third one, we need to move towards the right. So 1, 2, 3, 4, 5. So now that's basically 397 with 4 zeros. So that's 3,970,000. Now for the next example, we need to move towards the left. Since we have a negative exponent, it's going to give us a smaller number. 1, 2, 3, 4, 5. So then that's equal to 0.00468. Sometimes you may get numbers that are not in scientific notation or in the appropriate form, but you can still use the same principles to convert it to its decimal form. Now sometimes you may need to multiply two numbers in scientific notation. So let's say we wish to multiply 4 times 10 to the 3 by 2 times 10 to the 5. How can we do so? First, multiply 4 by 2. 4 times 2 is 8. And then multiply 10 to the third by 10 to the fifth. When you multiply by a common base, you need to add the exponents. So 3 plus 5 is 8. So the answer is 8 times 10 to the 8. Try these examples. Multiply 3 times 10 to the 5 by 2 times 10 to the minus 3. And try these as well. Let's say 3 times 10 to the 4 by 3 times 10 to the 5. And also 2.1 times 10 to the negative 4. And then 4.2 times 10 to the 6. So first, we'll need to multiply 3 by 2. 3 times 2 is 6. And then we're going to multiply 10 to the 5th times 10 to the negative 3. So if we add 5 plus negative 3, that's positive 2. So this is the first answer. Now for the next one, we're going to multiply 3 by 3, which is 9. And then 10 to the 4th times 10 to the 5th. So positive 4 plus positive 5 is positive 9. So it's 9 times 10 to the 9. Now for this one, let's use a calculator. Let's multiply 2.1 times 4.2. That's 8.82. And then we can add negative 4 and 6. Negative 4 plus 6 is positive 2. So it's 8.82 times 10 to the 2. And if you want to convert it to standard notation, that's 8.82 times 100, which is 882. Let's multiply 5 times 10 to the 4 and 7 times 10 to the minus 8. Try this one and be careful and make sure to put it in proper scientific notation. So let's multiply 5 times 7. 5 times 7 is 35. And 10 to the 4 times 10 to the negative 8, that's going to be 10 to the minus 4. Now this is not a final answer. We need to move the decimal 1 unit to the left. If you recall, anytime you move it to the left, the exponent should increase. So this is going to be 3.5 times 10 to the negative 4 plus 1 is negative 3. So it goes up by 1. And so that's it. Try this one. What is 12 times 10 to the 7 multiplied by 12 times 10 to the negative 4? 12 times 12 is 144. And then negative 7 plus negative 4, positive 7 plus negative 4, rather, that's positive 3. Now we got to move it 2 units to the left. So it's going to go up by 2. So it's 1.44 times 10 to the positive 5. And here's another one. What is 50 times 10 to the 4 multiplied by 30 times 10 to the minus 3? So 50 times 30. 5 times 3 is 15. You just got to add the 2 zeros. So it's 1500. 4 plus negative 3 is positive 1. Now this time, we got to move it 3 units to the left. So this is going to be 1.5 times 10. We got to add 3 to the exponent, so 10 to the 4th. Now let's talk about how to divide two numbers in scientific notation. So let's divide 12 times 10 to the 6 by 3 times 10 to the minus 4. So first you do 12 divided by 3, which is 4. And now 10 to the 6 divided by 10 to negative 4, what you need to do is subtract the exponents. So it's going to be the top exponent minus the one on the bottom. 6 minus negative 4 is the same as 6 plus 4, which is 10. So this is 4 times 10 to the 10, which is equivalent to 40 billion. So that's going to be the answer. If you want to know how to quickly convert scientific notation into decimal form, it helps to think of these numbers in terms of threes. For example, whenever you see 10 to the 3, think of 1,000. So this is 5,000. Whenever you see 10 to the 6, it's a million. So this is going to be 7 million. 10 to the 9 is 1 billion. So this is going to be 8 billion. That's a quick way just to do it mentally. So for example, if I have 4 times 10 to the 4, I know 10 to the 3 is 1,000. That means 10 to the 4 is the next level higher. That's 10,000. So 4 times 10,000 is 40,000. Let's say if I have 8 times 10 to the 7. If 10 to the 6 is a million, 10 to the 7 is 10 million. So 8 times 10 million is 80 million. And let's say if I have 3 times 10 to the 10. If 10 to the 9 is a billion, 10 to the 10 is 10 billion. 3 times 10 billion is 30 billion. So that's just a fast mental technique that you can use to quickly convert a number in scientific notation to standard notation. Let's work on some more examples. What's 28 times 10 to the 5th divided by 7 times 10 to the minus 3? Feel free to pause the video and try this example. So 28 divided by 7 is 4. And 10 to the 5th divided by 10 to the minus 3, that's going to be 10 to the 5 minus negative 3, which is 8. 5 plus 3 is 8. So this is 4 times 10 to the 8. Now we know 10 to the 9 is 1 billion. That means 10 to the 8 is 100 million. So 4 times 100 million is going to be 400 million. So that's 4 times 10 to the 8. What about 36 times 10 to the 7 divided by 4 times 10 to the 4? So 36 divided by 4 is 9. And 7 minus 4 is 3. So it's 9 times 10 to the 3. And 10 to the 3rd is 1,000. So 9 times 1,000 is basically 9,000. Try this one. 48 times 10 to the negative 4 divided by 6 times 10 to the negative 7. 48 divided by 6 is 8. And then 10 to the negative 4 divided by 10 to the negative 7. So it's going to be negative 4 minus negative 7, which is basically negative 4 plus 7. And that's positive 3. So this is 8 times 10 to the 3, which is equivalent to 8,000. And what about 96 times 10 to the negative 5 divided by 6 times 10 to the 2? Pause the video and work on that example. 96 divided by 6 is 16. And negative 5 minus positive 2 is negative 7. So this is 10 to the negative 7. Now this is not in proper scientific notation. So we got to move the decimal to the left. And when we move it to the left, the exponent is going to increase by 1. So this is going to be 1.6 times 10 to the negative 6. Now the next topic in our discussion is the addition and the subtraction of numbers in scientific notation. For example, let's say if we have 5 times 10 to the 3 plus 4 times 10 to the 3. If these are the same, you could simply add 5 and 4. 5 plus 4 is 9, so it's going to be 9 times 10 to the 3, which is 9,000. It's like adding 5x plus 4x, that's 9x. They're like terms. So let's say if we wish to combine 8 times 10 to the 4 minus 3 times 10 to the 4. Here we have like terms, so we can simply subtract 8 and 3. 8 minus 3 is 5, so it's 5 times 10 to the 4. And 10 to the 4 is 10,000, because 10 to the 3 is 1,000, so this is going to be 5 times 10,000, which is 50,000. Now sometimes you don't have like terms. For example, let's say if we wish to add 8 times 10 to the 4 and 2 times 10 to the 3. You can't say 8 plus 2 is 10 because these numbers don't match. What we need to do is convert one into the other. It's always better to convert the smaller number into the larger number. So we need to make this 3 and change it into a 4. So if you recall, anytime we move the decimal to the left, the exponent will increase. So what we need to do is move this decimal to the left. So this will increase by 1. So it's 0.2 times 10 to the 4. And this is 8 times 10 to the 4. So now that we have like terms, we can add 8 plus 0.2. 8 plus 0.2 is 8.2. So the answer is 8.2 times 10 to the 4, which is the same as 8.2 times 10,000. So that's 82,000. So now try this problem. 5.1 times 10 to the 5 plus 3.2 times 10 to the 4. So let's take the smaller number, or the smaller exponent, and convert it to the larger one. So we got to move the decimal 1 unit to the left. So this is going to be 0.32 times 10 to the 5. And let's add that with 5.1 times 10 to the 5. So now let's add these two numbers. So 5.1 plus 0.32. You can add a 0 if you want. So 0 plus 2 is 2, 1 plus 3 is 4, 5 plus 0 is 5. So it's 5.42 times 10 to the 5. If 10 to the 6 is 1 million, 10 to the 5 is 100,000. So 100,000 times 5.42, that's 542,000. Now what's 6.3 times 10 to the 6 plus 5.9 times 10 to the 4? So this time we need to move it 2 units to the left. So this is going to be 0.059 times 10, and we're going to add 2 to the exponent, so 10 to the 6. And let's combine that with 6.3 times 10 to the 6. So now that we have the same value, the same 10 to the 6 value, we can add 6.3 and 0.059. So 6.3 plus 0.059. Let's add 2 zeros. This is going to be 9, 5, 3, and 6. So it's 6.359 times 10 to the 6. And we know 10 to the 6 represent 1 million. So this is going to be 6,359,000, and that's it. Let's work on some examples involving subtraction. So as always, focus on a number with a smaller exponent. Let's make it or convert it to the one with the larger exponent. So let's move the decimal 1 unit to the left. So therefore this is going to be 0.42 times 10 to the 5. So now we got to subtract these two numbers. 8.30 minus 0.42. 0 minus 2 is a negative number, so we got to borrow on 1. This is going to be 2, and this is going to become 10. 10 minus 2 is 8, and then 2 minus 4 is negative, so we got to borrow on 1. 12 minus 4 is 8. 7 minus 0 is 7. So it's going to be 7.88 times 10 to the 5th power. And if you're not sure about your answer, you can always check with the calculator. If you type in 8.3 times 10 to the 5 minus 4.2 times 10 to the 4, it gives you 788,000, which is the same as 7.88 times 10 to the 5th. 10 to the 5th is 100,000. Now let's try one more example. 3.6 times 10 to the 7 minus 9.1 times 10 to the 5. So let's move this decimal 2 units to the left. So that's going to be 0.091 times 10 to the 7. We just got to add a 0 here. So this is going to be 3.600 minus So 0 minus 1 is negative, so we need to borrow 1. We can't borrow a 1 from this 0. So what we're going to do is borrow a 1 from 60. If we take away 1 from 60, this is going to change to 59. And this is going to become 10. 10 minus 1 is 9. 9 minus 9 is 0. 5 minus 0 is 5. And so it's going to be 3.509. If you type in 3.6 minus 0.091 in your calculator, you get 3.509. So it's 3.509 times 10 to the 7. And if 10 to the 6 is 1 million, 10 to the 7 is 10 million. 10 million times 3 is like 30 million. So this is going to be 35 million and 90,000 in standard notation. Now let's say if you want to find the square root of 4 times 10 to the 6. How can we do so if we're given a number in scientific notation? Well, first you want to separate it into two parts. The square root of 4 and the square root of 10 to the 6. The square root of 4 is 2. To find the square root of 10 to the 6, you need to realize that the index number is 2. So this is really times 10 to the 6 divided by 2 if you convert it back into its exponential form. So basically you're dividing 6 by 2. And so you get 3. So this is 2 times 10 to the 3, which is basically 2,000. Try this one. Go ahead and simplify 9 times 10 to the 8. So this is going to be the square root of 9 times the square root of 10 to the 8. The square root of 9 is 3, and the square root of 10 to the 8, you just divide 8 by 2, and so it's 4. So it's 3 times 10 to the 4, which is 30,000. Try this one. 25 times 10 to the 12. The square root of 25 is 5, and the square root of 10 to the 12, you just divide 12 by 2, so it's 5 times 10 to the 6, or simply 5 million. Now it works out the same way for negative exponents. So for example, if you want to find the square root of 36 times 10 to the negative 6, this is going to be the square root of 36, which is 6, and then divide negative 6 by 2, so it's 6 times 10 to the minus 3. Now what is the cube root of 8 times 10 to the 9? The cube root of 8 is 2, because 2 times 2 times 2 3 times is 8. Now the 9, you got to divide it by the index number, which is 3. 9 divided by 3 is 3. So the answer is 2 times 10 to the third, which is equal to 2,000. Now what about the cube root of 27 times 10 to the 12? The cube root of 27 is 3, because 3 times 3 times 3 is 27. The 12, we need to divide it by 3. 12 divided by 3 is 4. So the answer is 3 times 10 to the 4, which is 30,000. Now what is the square root of 1.6 times 10 to the minus 5? How would you do that? The square root of 1.6 is not a nice number. However, the square root of 16 is 4. So we need to convert the 1.6 into a 16. So we need to move the decimal 1 unit to the right. If you recall, if you move it to the right, the exponent will decrease by 1. So this is going to be 16 times 10, and then negative 5 minus 1 is negative 6. The square root of 16 is 4, and the square root of 10 to the negative 6, we need to divide negative 6 by 2, and that's negative 3. So this is 4 times 10 to the minus 3, which is 0.004. Try this one. Find the square root of 6.4 times 10 to the minus 7. So what we need to do is get 64. Let's move it to the right. So the exponent has to decrease again. So this is going to be 64 times 10 to the negative 8. So now we can square root each number individually. The square root of 64 is 8, and the square root of 10 to the negative 8 is negative 8 divided by 2. So this is 8 times 10 to the negative 4. And that's equal to 0.0008. Now let's work on two more examples. Sometimes you may need to square a number rather than taking the square root of a number. So what is 4 times 10 to the minus 3 squared? So what we need to do is square 4. So this is going to be 4 squared times 10 to the minus 3 squared. 4 squared is 16. And when you raise one exponent to another, you need to multiply. For example, x cubed raised to the 4th is 3 times 4, that's x to the 12th. So we got to multiply negative 3 by 2. So that would be negative 6. So it's 16 times 10 to negative 6. Now to put it in proper scientific notation, we got to move the decimal 1 unit to the left. As we move it to the left, the exponent should increase by 1. So this is 1.6 times 10. I'm going to add 1 to negative 6, so that's negative 5. Now what is 5 times 10 to the 4th raised to the 3rd power? So let's distribute the 3. So we got to multiply 1 times 3, which is 3, so it's 5 cubed, and then 4 times 3, which is 12, so 10 to the 12th. 5 to the 3rd power is 125. So now all we need to do is put this in proper scientific notation. Let's move the decimal 2 units to the left. So this is going to be 1.25 times 10, and now we got to add 2 to the exponent. So it's going to be 10 to the 14th. And once again, you could check it with your calculator if you type in the original problem.